Welcome to my talk, Our Invisible Journey to NanoMDM. I've been talking to a lot of you in the past 2 days, and I know that moving MDMs is not something that people really want to do because it's really difficult, but I would like to show you how easy it was for us to move from one MDM to another, and what you need to perform a migration without any hassle. So I'm Calvin. I am a production engineer at Meta. I've been working on macOS infrastructure for about 2 years, and this is my first time at MacDevOps because I am a fairly new Mac admin. So at Meta, we have over 100,000 devices in our fleet, which is a lot for a company that does its own IT infrastructure, which means that there are a lot of specific challenges that we have to go through that other companies don't. For example, we need our onboarding. We need a very efficient help desk. We need very transparent and highly available device management, which is what I'm going to be talking about. And we also need to be able to fix if things go wrong, get access to all of our devices. So what is MDM? Specifically, I am talking about the Mobile Device Management Protocol, which is the protocol by Apple for managing macOS, iPadOS, and now watchOS devices. MDM vendors offer agents that run on your device. As Katie mentioned, this protocol is pretty simple. There's just a couple of commands that you can issue and queries that you can make, and that's it. So most people use an MDM vendor such as Yamif or Kanji. At Meta, we have historically used MicroMDM, which is an open source MDM that you can run yourself. We like it because it's open source, which means we have access to all of our own data. We have access to errors that are going on. We can figure out why things aren't working. And in the past 3 macOS versions or so, MDM has become a lot more important because you have to perform more tasks through MDM. And so we've been putting a lot more load on our MDM. So we've been wanting to change to NanoMDM because it's much more efficient. It's easier to deploy than MicroMDM. It is also easier to plug into existing infrastructure. I really appreciate Joel's talk because he plugged NanoMDM into Dynamo, which is something that we, of course, don't do at Facebook. But it just shows that you can plug it into really anything. Here's an example of where MicroMDM has started to fail us. So MicroMDM uses a database called BoltDB, which has some performance issues. This graph shows the number of write operations that MicroMDM is performing. So higher in the graph means more write. Since MicroMDM is an IO-bound process, more write means it's operating slower, we're getting less performance, and devices aren't able to contact the management server as often. This is because BoltDB, as it gets more entries in its database, is slower to access. Specifically, each of these spikes are due to us pushing a profile to the fleet. We have very large profiles for configuring Google Chrome that are around 250 kilobytes. And if you scroll through them in system preferences, it crashes system preferences. So since MicroMDM doesn't do any duplication, this corresponds to roughly 25 gigabytes of storage in the database that we have to send out to devices. It just clogs everything up. And every couple of months, we have to run a program that cleans out the database and makes things efficient again, which we did on April 29th. So I need to talk about the MDM protocol itself a little bit so we can understand the difficulties and why you can't easily always migrate from one MDM to another. So the source of truth for an MDM enrollment is the enrollment profile. How you get the enrollment profile is not so important for this talk. Usually you get it through like Apple DEP protocol, the device enrollment protocol. You contact some web page that is predefined with Apple, and then you download a profile that contains a check-in URL and a bunch of other information of how your device is supposed to contact the MDM. The enrollment profile is entirely static for the lifetime of the MDM enrollment, and no aspects of it can be changed during the MDM enrollment. So specifically, the MDM protocol is URL-based, and this check-in URL will not be able to change. After your device installs the enrollment profile, it will send two very important messages to the MDM. This is an authenticate in teal message and token update message in pink. These contain information that are really useful for the MDM protocol to operate, and these are actually the most important pieces of state for the enrollment. The key insight into us moving from one MDM to another, spoiler for the rest of the talk, is that if you have this data, you have all the data you need for your enrollment. Then, this is how the MDM protocol usually operates. If your MDM wants to issue a command or query to a device, then it contacts the Apple push notification service with the information gathered in the last two messages. APNS then contacts the device, asking it to check in. The device checks in, and the MDM can tell it things to do, which is issue a command. You can also do nothing, but you can also tell the device to check in elsewhere if you give it an HTTP3XX response, which is useful because even if you are using an MDM, such as Kanji, but you could put an MDM in front of it and just redirect to Kanji using HTTP3XX. And so you can always run an MDM and then redirect to another one. You can also unenroll your device with an HTTP 401, and there's new stuff that's being added for software update in Sonoma, which is really interesting. Anyway, to summarize the protocol, your device installs an enrollment profile, which is static. It then sends the necessary information to the MDM server, and this information is used throughout the entire enrollment. So let's talk about migrating MDMs. Re-enrolling, so let's talk about how to re-enroll and re-enroll a device. So first, you have to unenroll a device from MDM, which you can perform through the MDM server through the HTTP 401 response. You can just tell a device to unenroll itself. Then, if your device wants to re-enroll into MDM, you can kick off a DEP enrollment in the shell by running sudo profiles-n. However, a user has to manually approve this enrollment. They get a notification that looks similar to this, which they have to click on and go to their system settings in order to enroll. You can also download an enrollment profile manually, which has to be double-clicked, reviewed in system settings, and then installed. So however you re-enroll your device, you need a user to manually approve it. It's a very manual process, and if your user doesn't approve the process, then you remain unenrolled. This is not impossible to do, especially if you have a rather small fleet in comparison to us. So I recently read a blog post called Moving Day by Jacob Erdley, where he moved his fleet from one MDM to another by re-enrolling every device. They did this by guiding a user through the re-enrollment process. So they created a Swift dialog notification, which then prompted the user to say they were ready to perform their re-enrollment. After they clicked, "I'm ready," YAMP would unenroll the device. Then it would kick off a DEP enrollment in the shell. The user would have to click on this notification that they would receive, but they would be pre-prompted to do it, so they would usually do it. And then it would re-enroll an MDM. So devices were temporarily unenrolled during this process, which means they were slightly unmanaged. But all the devices were running Monkey Report, and they modified Monkey Report to contact their services and continue reporting while the devices were unenrolled, so they knew what was happening with the devices. They could track them down with Help Desk. They maintained a spreadsheet of all the devices, and they moved all 1,000 of their devices in about a month, not involving employees on parental leave who didn't have access to their devices. This isn't as possible at Meta for several reasons. We very much prioritize transparency in our management, and we don't want to make every single user perform a task. One task on 100,000 devices is really a lot of work, And we don't actually really know where all the devices are because the users could be on parental leave. The devices could be in desks somewhere. They could be left in the office and the user could have gone remote. And it's very difficult to track them all down. We also need efficiency in our IT teams, which means that we can't have the help desk manually re-enrolling every single device. And we can't be maintaining multiple MDMs for multiple years while we wait for a re-enrollment to happen. Finally, we care a lot about security, and users can't use their devices when they are unenrolled. So if something goes wrong, a user might be unable to work for a week or so, which would really not be good. We also care about device attestation, so we want to make sure the device that enrolls into another MDM is the exact same device that was enrolled in the previous MDM. And so these create more issues to solve. So here's how we performed our MDM migration. First, we got MicroMDM and NanoMDM both running in our infrastructure. And we taught NanoMDM, the open source project, to speak the MicroMDM webhook protocol to talk to our management logic. So both MicroMDM and NanoMDM could talk to it together, and devices in either would be managed. We also attached an instance parameter to the messages to our management logic so that it would know what MDM to contact to manage the device. This is not only useful for MDM migrations, but it's useful for testing because we are now running a test instance, which then we can canary new changes to so we don't break the fleet. Then, after we had both of the MDMs running, we needed to transfer our traffic from one to the other. If we did this while devices were enrolled, the enrollments would be broken because NanoMDM would be unable to manage the devices. So we used the open source micro to nano program to transfer enrollment data from the MicroMDM database to NanoMDM. And how it worked was pretty clever because it just sent spoofed token update and authenticate messages, pretending as if it was a device, to NanoMDM from MicroMDM, which was just a really simple way to implement it because NanoMDM knew what these messages meant and it knew how to put them in its database. Then we paused enrollments into MicroMDM so no devices would get lost. We transferred every single enrollment over to the NanoMDM database. We drastically lowered the TTL on our DNS for a check-in URL to 5 minutes, and we moved the DNS from MicroMDM to NanoMDM. Because the TTL was 5 minutes, the migration took less than half an hour, although we allowed for a 2-hour maintenance window to make sure that all the devices transferred over and that everything was working okay. The devices that were checking into MicroMDM in one moment were checking into NanoMDM the next moment, and they didn't really notice. There was nothing that the users had to do for the migration to happen. It's pretty cool, right? So here's what happened during and after our migration. So we did have a bug, and I wanted to talk about this because migrations like this never really go perfect, and I want you to know what can go wrong. So you need your API for both MDMs to be exactly the same so you can access them at the same time. And so MicroMDM has an API where it can tell you when a device last contacted the MDM, and we use this to check the health of devices. It gave back an RFC339 date, so we implemented this in NanoMDM to just check the database and give back a date of when the device last checked in. Well, this is SQL, and you can just return things like quote null unquote if you do it wrong, which is not an RFC339 date, which is different from the MicroMDM behavior. So we wrote a diff to return just a 0 date, and everything started working. This affected one of our controllers for certificate enrollment. I think 1 or 2 users ran into this bug, and it was the only code that I actually had to write during the migration. Let's talk about NanoMDM performance. This is a graph of the number of check-ins to NanoMDM on a single day. As you can see, we normally get around 100 to 200,000 check-ins a day, which corresponds pretty well to our 100,000 devices. I looked at our graph of check-ins in the beginning of May, and I saw that we were getting around 8 million a day, which was a little bit weird because we don't have that many devices. Now we let the production macOS people who have data center Macs use our service, and they had a bug where after they provisioned their devices, they would request a command, and we'd give them a command, and they'd say, no, we don't want a command, and they would just do that in a loop, and we ended up having much higher load on our service than normal. I've also graphed the CPU usage of our service, and it went from 0.2% to 1%. So NanoMDM is pretty performant, and we haven't actually run into any sort of scaling issue, any sort of performance issues like we have with NanoMDM. And this is because it's designed differently. NanoMDM is easy to scale horizontally, and we run 3 different processes for it in 3 different regions around the US. So we have 9 instances serving MDM traffic, unless if an update is happening. And we have 10 serving API traffic to our backend logic. We are also using a massively distributed MySQL database with very performant, well-indexed queries, which means that we don't run into I/O-backed performance issues like we did with MicroMDM. NanoMDM is also much easier to plug into existing infrastructure. So we taught it to speak Thrift, which is our RPC framework. You could just as easily teach it to speak gRPC or REST or anything else. We also taught it to plug into our logging infrastructure so we could more easily catch bugs. So this is a bug that was happening with both MicroMDM and NanoMDM. This is a token update message that got sent from a device. Token update is a user level enrollment, so it includes the user's full name, first name and last name. Can anybody see what's wrong with this plist? It has this shift in character, which is, I've never seen it before. They also include data link escape every once in a while, which I've also never seen before. I don't know why the MacBooks are doing this, but it's invalid XML. They shouldn't be doing this. We see like 1 or 2 every day. And this was happening with MicroMDM too. MicroMDM was having bugs. It couldn't parse these, but we didn't know because it was just logging it to systemd logs that Jesse checked once a month. But I mean, now we saw these, we were able to debug them, we were able to contact the help desk and get users to change their username field, which fixed this issue. So as Joel said, NanoMDM does one thing really well and not very much else. It's not like a large MDM vendor. But it comes with a growing suite of software that is doing more and more, and it's growing every day. So NanoDEP is a piece of software that we are currently integrating, that we have integrated into Meta Device Management for the Apple DEP protocol to replace MicroMDM. NanoCMD was also recently released, which is can perform complex MDM workflows like pulling a device for its state, making sure that it's in compliance, and then issuing commands to the device, the chatty protocol that was mentioned by Katie in our last talk. We have also been working on KMFDDM, and by we, I mean Jesse, for all of these. He wrote all these different pieces of software. This is a declarative device management server, which we're trying to start to use more and more. And DEP-WebView-OIDC was recently just released by Corey Prince, so we're having more people write software for easily integrating DEP with different open identity standards. Okay. So finally, if you want to have an easy MDM migration, these are the most important things to know. First, the only reason that we were able to change MDMs without people noticing is because we owned the URL that was used for the devices. you can't ever change the URL when a device is enrolled, so you can only make that URL point different places. You can also put a piece of software behind it that just operates as a proxy and sends redirect requests or otherwise to the devices. So as an example, we're trying to change the URL in some of our device enrollments. We're just trying to add a parameter to add some more data so we know what devices are doing what. And we expect that to take 3 or 4 years to finish because we have to wait for devices to be sent back, taken out of management, and new devices to be sent in. The other important thing is you need to own your data. And this is more important than the fact that we use MicroMDM, that we use NanoMDM, or that we used open source software at all. Because we had access to our database, we were able to retrieve the information that was first sent to MicroMDM and then replay that to NanoMDM so that NanoMDM had the enrollment information. The Apple device management specification says that you can never expect a token update message to be sent to an MDM once it's sent for the first time. So you need to make sure to capture that. That's my talk. Thank you.